students, welcome back with new lesson with physics grade 10. Today we will speak about atomic model. We will study atomic structure and what is an atom and another model of atoms. Thomson model, discoveries of protons, discovery of neutrons, Rutherford model, Bohr models, subparticle and atom, valency shell, atomic number, mass number, isotopes, isobar, and end with a conclusion about each model. Introduction. At first, atom was discovered by John Dalton. He proposed the famous atomic theory in 1807. Atoms are fundamental unit of matter. The existence of different kinds of matter is due to different atoms constituting them. A major challenge before the scientists at the end of the 19th century was to reveal the structures of atoms as well as to explain its important properties. Many scientists worked hard and proposed many models for the atom. Here we are going to learn about the structure of an atom. The structure of an atom. The discovery of the two fundamental particles, electrons and protons, inside the atoms led to the failure of the aspects of Dalton's atomic theory. For explaining the arrangement of the electrons and protons in an atom, many scientists proposed various atomic models. What if matter is anything that takes up space and has a mass? All matter is made of atoms. Atoms are the building blocks of matter, sort of how bricks are building blocks of house. Like the building of house, the smallest part of the wall is brick. The atom is the smallest building unit of the matter. This is the timeline of atomic theory. Start with Greek model about 400 years BC. After that, Dalton model about 1803. After that, Thomson model 1897. Rutherford model 1911. Bohr model 1921. At the end was wave model. This is the John Dalton theory about atom theory. All matter is made up of atoms. Atoms of an element are identical. With this postulate, which say elements are identical atoms. Elements are identical. All elements have the same atoms. This is not right. Each element has a different atoms. Atoms can engage in chemical reactions. That's right. Atoms can neither be created nor be destroyed. That's right. Thomson Plum Petting model. In 1897, the English scientist Thomson provided the first hint that an atom is made of even smaller particles. So, Thomson is the first one to speak about subparticles or subatomic particles. We will know that what is these particles. Thomson models. Thomson models, he proposed a model of the atoms that is sometimes called the pudding model. Atoms were made from a positively charged sphere with negatively charged electrons embedded in it, like raisins in a pudding, like sphere, and electrons distributed on the surface of this sphere. The negative and positive charges are equal in a magnitude, so that atoms as a whole is electrically stable. It means this is yellow sphere is a positive charge and this is a negative charge electrons is, but he didn't call a positive charge or negative charge, what its name, proton or electrons, but he supposed the positive charge is a sphere and the negative charge is a particle distributed on the surface of the positive charge like this. But he said the negative charge equals the positive charge, so the atom is stable. Thomson experiment, voltage source, positive and negative. This is electric field applied to this tube. This tube is connected with voltage source. This is a positive and this is a negative. A beam of electron or charge come from negative plate to positive plate. By applying electric field with the negative and the positive, he found that the beam changed its directions to the positive electrode. By adding an electric field, he found that the moving pieces were negative. He called this a moving pieces electron. The electron was discovered in 1897 by Thomson. He imagined the atom as a rising padding with electrons stuck in a cake of positive charge. Discovery of protons. Goldstein noted streams of positively charged particles in a cathode rays in 1886. Particles move in opposite direction of cathode ray, called canal rays, because they pass through holes, channels or canals drilled through the negative electrodes. Canal rays must be positive. Goldstein postulates the existence of positive fundamental particles called the protons. Anode, the electrons, this is the red particles, is electrons come from cathode to anode. Also, there are particles emitted from anode to cathode. These particles is positive charge. We call it canal ray, and it called protons. Discovery of neutrons. In 1932, Chadwick discovered another subatomic particles which had no charge and mass nearly equals to that of protons. It was eventually named as neutron. Neutrons are present in the nucleus of the atoms except hydrogen. In general, the neutrons is represented as N. The mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus. Proton has the same mass of neutrons, but protons is positive and the neutron is a negative. All atoms has a nucleus. Inside the nucleus has protons and neutrons except hydrogen. Just hydrogen didn't have neutron, just has one proton. This is neutron and this is proton. This brown sphere is neutron without charge, but yellow sphere is protons with a positive charge. Rutherford gold foil experiment. Rutherford make experiment using gold foil in 1908. The English physicist Ernest Rutherford was hard at work on an experiment that seemed to have a little to do with unraveling the mysteries of the atomic structure. Rutherford's experiment involved firing flame of a tiny positively charged alpha particles at a thin sheet of gold foil. The expected result was that the alpha particles would be deflected by the subatomic particles in a gold atoms. Since alpha particles were much heavier than protons, he didn't expect to see large deflections. It means if the atom have subatomic particle like electron, proton, neutron, so if we have a foil or gold foil, the alpha particles, it must scattered, not deflected from the gold foil, but his experiment gave another result. This is a foil or gold foil sheet, and this is the source of alpha particle ray. We see this is a shield of fluorescent. This shield, with the alpha particles knock it, it will have spark or light spot. He found that most of alpha particles pass through gold foil and make spotlight on the fluorescent sheet, but little of alpha particles has scattered from the foil. It means most of the nucleus or most of the atoms is empty or is space. What was an expected result? Most of the positively charged belt passed right through the gold atoms in the sheet of the gold foil without changing course at all. Some of the positively charged belts, however, did bounce away from the gold sheet as if they had hit something solid. He knew that positive charge repel positive charges. This only means that the gold atoms in the sheet were mostly, yes, open space. Atoms were not budding filled with positively charged materials. Rutherford concludes that an atom had a small dense positively charged center that repelled his positively charged belts. He called the center of the atoms the nucleus. The nucleus is tiny compared to the atoms as a whole. It means nucleus is very small compared with the atoms. It means the atoms is space, as most of the atom is space. Rutherford postulates. Rutherford reasoned that all of the atom's positively charged particles were contained in the nucleus. It's right. The negatively charged particles were scattered outside the nucleus around the atom's edges. It means the negative charge at the edges of the atom, but the positively charged are contained or concentrated in a nucleus inside that. Planetary model of atoms like a solar system. This is the solar system. So this is the sun, represent the nucleus of atom, and this is planet, represent electron. Rutherford atom model. The model created by Rutherford had still some serious discordance according to the classical science. Or according to the classic science, electrons moving around the nucleus or the planetary models of an atom is unstable, because in the planetary models of atoms the electrons should radiate energy and finally fall into the nucleus. It means the atoms give out radiation. How the electrons give out radiations if electrons move in the same shell or have the same path around the nucleus, okay? Or if the atom or if the electrons continuously emit energy, it means it will take a path to fall inside the nucleus, and this is not right. Bohr model in 1913, the Danish scientist Niels Bohr purpose and improvement in his models, he placed each electron in specific energy level. Bohr change or recorrect or Rutherford model, he said electrons moving in a specific energy level and just change its level from down to up or from up to down. Following Rutherford's planetary models of the atoms, it was realized that the attractions between of electrons and the protons should make the atoms unstable. Bohr proposed a model in which the electrons would stably occupy fixed orbits as long as these orbits has or had a specific discrete location. It means electrons moving in specific orbits. These orbits have different level of energy. This is a Bohr's model. This is a nucleus with a positive and negative charge, with a positive charge protons and the neutrons with a neutral charge, and electrons take specific orbits around the nucleus. This is the orbit, this is electrons, this is energy level. Bohr's models of atoms, the specific orbitals known as discrete orbits of electrons are allowed inside an atom. These orbits or shells are represented by letters K, L, M, N. It means first, one, second, third, fourth, K, L, M, N. He called by letters or the numbers N equal 1, 2, 3, and 4. Bohr's model of the atoms, electrons falls in the orbits closest to the nucleus. F99 fluorine, protons 9, electrons number is 9, nucleus have 9 protons and 10 neutrons and 9 electrons around the nucleus. Bohr's model of the atom, each orbit can hold a specific maximum number of electrons, and either way to calculate the total numbers of electrons that can be held by a given energy levels is to use the formula 2 multiply n square. It means n take 1, 2, 3. If the k it's number 1, if we substituting in this formula, it means 2 multiply 1 square is equal 2, and L 2 multiply 2 square equal 8, 2 multiply 3 square equal 18. This is the formula we can calculate the number of electrons in each shell or energy level. Case aspects of Bohr's model. Electrons move around the nucleus at stable orbits without emitting radiations. It means if the electrons are moving in specific orbit, it will emit radiation. Electrons in one of these stable orbits has a defined energy. Energy is radiated only when, yes, this is problem which Rutherford can't prove it. Prove it like this: energy is radiated only when electrons make transitions from high energy orbits to a low energy orbit. But if the electrons move in the same orbit, won't emit any energy. Subparticles in an atom: electron, proton, and neutron. What is in the structures of an atom? Nucleus, center of the atom, home of protons and neutrons, has a positive charge. Nucleus, center of the atom, form of proton and neutrons has a positive charge. Proton has relative mass of 1 unit, has a positive charge, determines the atomic number found inside the nucleus. What is in the structures of an atom? Also, neutrons has no charge, has a relative mass of 1 unit, the same mass of protons found inside the nucleus. Electron has a negative charge found outside the nucleus. Rutherford atoms models electrons are around the nucleus. Bohr models electrons are in a specific energy levels called shell. But what about the mass of electrons? The mass of electrons is negligible compared with the mass of proton and neutron, so the most mass of atom is concentrated in nucleus. Like the solar system, the sun is the most mass of the solar system. It about 96% of the mass of solar systems concentrated inside the sun. How are P and E related? P, proton, and neutron. E, electron, is related. Number of protons equal number of electrons. Number of protons called atomic number. Number of proton plus number of neutron inside the nucleus called the mass number. Number of neutrons equal mass number minus atomic number. So if we want to calculate the number of neutrons, we take number of protons or mass number minus atomic number. This is a symbol about writing. This is symbol to write any element. This is X represent element, maybe H, N, O, F, F, E, like this. And A is mass numbers, is the number of proton plus number of neutron. And Z is atomic numbers, number of protons. And mostly or usually number of proton equal number of electron. Valence, the outermost shell of an atom, is known as its valence shell. The electrons represented in the outermost shell of an atom are known as the valence electrons. The valency of an element may be defined as the combining capacity of its atom with atom of other element in order to occur octet configuration. For example, the valence of hydrogen is 1. It means the hydrogen need take 1 electrons to be complete the outer shell to have 2 electrons, or left or lost 1 electrons to be stable. Valence electrons, it means number of electrons which atoms need to gain it or lost it to be stable. The number of protons in an atom is referred to its atomic number. It is denoted by the letter Z. Elements are defined by the number of protons they possess. The atomic numbers of hydrogen is 1. Mass number of an atom. The mass of an atom resides in its nucleus. The mass of an atom is practically due to protons and neutrons alone. Therefore, mass numbers of an atom is the sum of neutrons and protons present in the nucleus of an atom. For hydrogen, its mass number is 1 unit. Isotopes. What's the meaning of isotopes? Isotopes are atoms of same elements which have different mass numbers but have the same atomic number. Their chemical properties are similar but physical properties are different. It means hydrogen have 1 proton and 1 electron. but may have one proton and one neutron and have the same one electron, and maybe have two proton, two neutron and one proton and have one electron. It means atomic number is the same in the three isotopes but have a different in mass number. Mass number is here is 1, mass number here is 2, here is 3. So isotopes is the element that has the same atomic number but have a different in a mass number. An isotope of uranium is used as fuel in nuclear reactors. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used to treatment of gout. Isobars, atoms of different elements with different atomic numbers which has the same mass numbers are known as isobars. Examples of isobars are calcium, Z equal 20, Z is atomic number 20, and argon, Z equal 80. Their mass numbers is 40 unit. So isobar is the opposite of isotopes. Isotopes have the same atomic number and different mass number, but isobar has a different atomic number but has the same mass number. Conclusion: atoms are building blocks of matter. Thomson's atom models is that atoms is a positively charged sphere and the electrons are embedded in it and atoms are neutral. Rutherford did the famous gold foil experiment and said that there are positively charged centers in the atoms called the nucleus, and the electrons revolve around the nucleus in a circular path. Bohr was the next person. He proposed that only specific discrete orbits are allowed inside an atom, and while revolving electrons doesn't radiate energy. The subparticles in nucleus is electrons, protons, and neutrons. Valency is the combining capacity of atoms. Atomic numbers is the numbers of protons. Mass numbers is the sum of numbers of neutrons and protons in an atom. Isotopes are atoms of the same element which have different mass number and same atomic number. Isobars are atoms which has the same mass numbers but different atomic number. Thank you and goodbye with a new lesson.